Calculus AB, doing some notes over L'Hopital's rule. L'Hopital's rule is very valuable when you're taking limits. And if the limit ends up being an indeterminate form is when the top and the bottom are both 0, or the top and the bottom are some version of infinity. So formally, L'Hopital's rule. If the limit, as x approaches c of f over g, produces the indeterminate form of either 0 over 0 or infinity over infinity, then you can evaluate this original limit by taking the limit of the derivative of the top and the bottom.
Max Speed, report to the office, please.
So this is super powerful. You can't use it for all limits. You can only use it for a limit that's of an indeterminate form. Let's see how this works. We first want to figure out, does L'Hopital's rule even apply to this? Well, if you were to do this limit, if you were to apply the 0 into the numerator, you would have sine of 0, 0. Put 0 on the bottom, you would get 0. This would end up being 0 over 0. So we don't want to write this is equal to 0 over 0 because it doesn't. We would want to say that this produces the indeterminate form (0 over 0). Did I spell indeterminate right? Of course I didn't. Since that produces the indeterminate form, we can apply L'Hopital's rule. So that means that the limit of sine of x over x as x approaches 0 is going to have the same answer as the limit as x approaches 0 of the derivative of sine of x over the derivative of x. The limit as x approaches 0, derivative of sine of x is cosine of x. The derivative of x is 1. So that means this is going to be equivalent. I said x is 1 and I wrote x. This is equivalent to the limit of cosine of x as x approaches 0. To evaluate this limit, if we put 0 in for x, what is cosine of 0? Cosine of 0 is 1. So that means this original limit, using L'Hopital's rule, we know that it's equal to 1. If you think back, we actually learned the special rule for this earlier. You now no longer have to memorize that special rule because you can use L'Hopital's rule without memorizing that. Let's check out another. First of all, is this the indeterminate form? Well, let's see. Put 0 into the bottom, you would get 5 times 0, which is 0. Well, that would be 0. Put 0 into the top, cosine of 2 times 0. That would be the same as cosine of 0. Cosine of 0 is 1. 1 minus 1 is 0. This also produces the indeterminate form 0 over 0. So we can apply L'Hopital's rule. Which says that this limit is going to be equivalent to a limit of the derivative of the top and the bottom. So we got to take the derivative of the top and the bottom of this. Bottom is much easier than the top, not always the case. Derivative, let me not forget, this is the limit as x approaches 0. You got to keep using limit notation until you're no longer finding a limit. The derivative of this top, derivative of 1 is 0. Derivative of cosine of 2x, that's the chain rule. So the outside is negative cosine. Its derivative is going to be sine. Derivative of cosine is negative sine. If we already have a negative there, negative times a negative is a positive. So this is the limit as x approaches 0. So it's going to give us sine of 2x, because the inside stays the same. Then we multiply this by the derivative of the inside, which is a 2. Just going to make a note here. This is the chain rule. The denominator, derivative of 5x, is just 5. To evaluate this limit, the bottom is clearly 5. There's no variable there. On the top, if I put a 0 in here for x, it's going to be sine of 2 times 0. 2 times 0 is 0. Sine of 0 is 0. So we're going to have 2 times 0 on the top. That's going to make this 0. So there is L'Hopital's rule in action. Now let's check out just three of these little problems here. Should we apply L'Hopital's rule? In other words, does this determine the indeterminate form? Well, on the top, sine of 0 is going to be 0, so the top would be 0. On the bottom, you'd have 0 squared, which is 0, times 2 is 0. 0 minus 1 is 0. This does not produce an indeterminate form, so L'Hopital's rule does not apply. It only applies if you have an indeterminate form. Top and bottom are 0, top and bottom are some form of infinity. How about B? Well, the top, if you put a 2 in, you get sine of 2. Well, sine of 2 is not 0 or infinity or negative infinity. And then you have to check the bottom. It doesn't apply. C, which is Spanish for yes. If I put a 2 into the top, 2 minus 2 is 0. Sine of 0 is 0. 2 on the bottom, 2 squared is 4. 4 minus 4 is 0. L'Hopital's rule does apply, because we got the indeterminate form 0 over 0. And I'm just going to write that down in the cheatingest way possible. Let's look at 2 more examples, and then we'll stop this video. Find each limit. Maybe we have to use L'Hopital's rule, maybe we don't. If I put a 1 into the x here at the top, natural log of 1 is asking the question. Natural log of 1 is asking e to what exponent is equal to 1. That would be e to the 0. So this top is going to be 0. On the bottom, 1 squared minus 1 is also 0. So this produces the indeterminate form, 0 over 0, which means we can apply L'Hopital's rule. So the limit as x approaches 1 of natural log of x over x squared minus 1 is going to be equal to the limit as x approaches 1. If you recall, the derivative of natural log of x is 1 over x. Derivative of x squared minus 1 is 2x. Evaluating this at 1, we're going to get 1 over 2 times 1, and I believe you'll agree this ends up being 1/2. Check out a table of values. The table gives a selected values of a twice differentiable function. Anytime you're told it's differentiable, that implies that f of x is continuous. Write that down in your notes. You don't have to write that down every time you see it, but you should think it every time you see it. Supposed to find this limit. Let's see if it's the indeterminate form, first of all. If I put a 3 into the bottom, 3 squared minus 9 is going to be 0. If I put a 3 in the top, 2 times 3 is 6, minus 1 is 5. But what's f of 5? According to this table, f of 5 is 0. This is the indeterminate form. You have to write this every time. On the AP Calculus test, if you don't write that, they're not going to give you credit for it. So let's use L'Hopital's rule. So the limit as x approaches 3 of f of 2x minus 1 over x squared minus 9 is going to equal the limit as x approaches 3 of f of 2x minus 1 prime over x squared minus 9 prime. Derivative, if you will. Derivative of the top is going to be the chain rule, once again. The bottom is just the power rule. I'll just do that one first. It's easy. For the top, take the derivative of the outside, which is going to be f prime. Inside stays the same. Then you multiply this by the derivative of the inside. The derivative of the inside is 2. I like to put that out in the front. Just to make a note, this is the chain rule. So what is this limit? Well, let's put the 3 in. To evaluate the limit, we're going to use substitution. If I put a 3 into the top, 2 times 3 is 6. 6 minus 1 is 5. So that's f prime of 5. If I put in the bottom, you're going to get 2 times 3, which is 6. According to my table, f prime of 5 is a 7. So this is going to be 2 times 7 over 6, which is going to be 7/3. That concludes the first video. The second video, I'm just going to look at some AP style types of questions.